Welcome my students and viewers as well. In the previous videos, I explained the Karl-Pearson correlation coefficient in quite detail along with the mathematical properties of Karl-Pearson correlation coefficient. Thereafter comes this rank correlation, the Spearman rank correlation, which is going to be explained in this class itself. One thing has to be understood at the very outset, that the Karl-Pearson correlation coefficient is defined only when the both variables x and y are quantifiable variables. If it can be quantified, like height and weight, age. So if such variables are there which can be quantified or can be expressed in numbers, then Karl-Pearson correlation coefficient is quite relevant. But at some places, in some situations rather, variables becomes qualitative. And when the variable has become qualitative, this Karl-Pearson correlation coefficient becomes irrelevant. In that case, we go for some another technique, that is a rank correlation given by Spearman. And this Spearman rank correlation is defined as, this is expressed by the letter rho xy instead of r. R was used for particularly for the Karl-Pearson, and for Spearman rank we shall be using, or it is rather the common practice to use rho for rankings in mathematics. In entire mathematics, rank is denoted by rho. Here it is rank correlation. So rho xy is 1 minus 6 summation d square divided by n into n square minus 1. Two things regarding this formula. This formula has to be used if in x and y rankings there are no repetitions, one thing. And secondly, this d is, absolute d is the difference of ranks of x and y. So rank of x minus rank of y, or rank of y minus rank of x, that's why we take the absolute value, because it has to be squared up. So this formula. In case of repetitions, in x column, in y column, if we do have the repetitions, and let there are n repetitions, r1, r2, rn, these are the repetitions, then this formula is a little bit extended. So here 6 summation d square plus r1 cube minus r1 by 12. 12 is a part of the formula, which has nothing to do with the sum, nature of sum. Plus r2 cube minus r2 by 12 dot rn cube minus rn by 12. Now which components or how much components will be used, that depends upon the number of repetitions in the sample or in the given sum, and this divided by n into n square minus 1. Thirdly, like Karl-Pearson correlation coefficient, this rho xy also lies in between minus 1 and plus 1. This minus 1 and plus 1 value of this rho xy could happen if rho xy is plus 1, if summation d square is 0. In this formula, if it is 0, then this entire becomes 0 and rho xy is 1. So if summation d square is 0, rho xy becomes plus 1. And if this component becomes 2, then rho xy becomes minus 1. So these two limiting values could be obtained only under these two situations. If summation d square is 0, then rho xy is 1. And if summation d square by n into n square minus 1 is 2, then rho xy becomes minus 1. So this is all about the use of the formula. Now, when going to the mathematical side or the sum portions, related to this Spearman Karl-Pearson, three kinds of sums could be asked. At one place, already ranks of x and y are given. Rank of x and rank of y is given in the sum, and then we have to proceed. Alright, so this is one type. In second type, when ranks are not given, in such cases we have to assign ranks from our own side, and when we get the ranks, then we shall proceed as earlier. And this number third case is a case of repeated ranks or tied rank. Might be in a class, two students gets the same number. So this happens much. So in case of triad rank or repeated ranks, how we assign the ranks, and in this case, this formula will be used. I have explained already. So one sum from each category I am going to solve in the class right now. Number one type states that when the ranks of x and y are given, and then we have to calculate rho xy. So this first category, when ranks are given, in such case, let this is rank of x and this is rank of y. Let it is like this. Five number of observations. So n is 5. These are the ranks only because that in both this Rx column and Ry column, there is a play of number from 1 to 5. 5 objects have to be ranked, then definitely number from 1 to 5 will be used. So this is a play of number 1 to 5. This is as well, it is a play of numbers of 1 to 5. So absolutely these are the ranks. Now from this, we have to find absolute D, ignoring negative sign, and then is it D square. So this is 3, 1, 2, 1, 3. Get it squared. 9, 1, 4, 1, 9. And this is 24 summation D square. Hence, rho xy is 1 minus 6 summation D square by n into n square minus 1. 1 minus 6 into 24 and divided by 5 into 5 square minus 1. This is 144 divided by 5 into 24. This is 1 minus 144 by 120. And this is minus 24 by 120 minus 1 by 5, and hence it is minus 2. So when the ranks are given, quite simple, we just calculate D, ignoring the negative sign because that has to be squared up. So D and D square, and by simply using this formula, we get the Spearman rank correlation, this is rho xy. So this is the case when the ranks are already given. Now second variety was when ranks are not given, rather in some absolute values of x and y are given, but we have to calculate rank correlation. So in that case, we shall have to assign ranks from our own side when ranks are not given. Let the sum is like this. This is x and this is y. And rank correlation has been asked. Definitely n is 5. If these numbers would have been the play of numbers from 1 to 5, like in the previous sum, that would have been the rank. Similarly in this case, so definitely these are not the ranks. Had it been calculation correlation coefficient, it was alright, simply we have proceeded, we could have proceeded, but this here rank correlation had been asked, so definitely these are not the ranks. So we shall have to assign rank for our own side, rank of x and rank of y. And while assigning ranks, largest number gets the rank 1, this formula has to be used. So 50, rank 1, 42, rank 2, 38, rank 3, 28, rank 4, and the smallest 20, so rank 5. In this case, largest number 94, rank 1, this is 2, this is 3, this is 4, and this one is 5. So, if these are the ranks, then there is a play of numbers from 1 to 5, 1, 2, 3, 4, 5. This is, so these have become the ranks, and now we get the D, 2, 1, 1, 1. Get it squared. So 1, 4, 8, and this is summation D square. So a Spearman rank correlation rho xy is 1 minus 6 summation D square by n into n square minus 1. So 1 minus 6 into 8 and 5 into 5 square minus 1. So 1 minus 48 divided by 5 into 24, and this becomes 1 minus 48 by 120. So this is 72 by 120, and this is 0.6. So this is how we just calculate rank correlation when the rank of x and y are not given. And finally, we could have a situation when there is a repetition of the numbers, like what we have seen right now in the x column and y column, in any one column or in both of the columns. That could be the situation when a number is repeated twice, thrice. Then in that case, how we should proceed and should calculate a third case, case of repeated ranks, a case of repeated ranks. Now let me have a sum from the book, and then I am going to explain it. So these are the x column, and in y column so this is the sum, and rank correlation had been asked. Now, first of all, it is obvious that n is 10. Yes, n is 10. Since these are not the ranks, these are the absolute values, so we are supposed to assign ranks. So this absolute x and y has to be converted into rank of x and rank of y. A little bit work has to be done here. Now, while assigning ranks, we look for the largest number which corresponds to the rank 1. So, in this X column, definitely the largest number is 65, its rank is 1. Next to 65 is 57, its rank is 2. After 57, it is 48, 3. Then it is 40, 4. And thereafter 33, 5. Then 24, 6. Now, after 24, we have three numbers, identical numbers, 16, 16, 16. So, first repetition is 3 in that is X column, 16, 16 and 16. Here, while assigning ranks, up to 6 ranks have been exhausted. So, for the next 3 ranking, we have to use the ranks 7, 8 and 9. But these 3 are the identical numbers. So this 7, 8, 9, add it up, it comes to 24 and divided by 3 since it is 3 numbers. So 3, so 24 by 3, 8. So these 3 numbers will have their ranking 8, 8 and 8. And 7, 8, 9 ranking has been exhausted and the smallest number is 9, its ranking would be. So this is how, and this is called average ranking method. Mind it, this is average ranking method. Now come to this table. Column Y. In column Y, 24 is the largest number, it will have its rank 1. Thereafter it is 20, which will have rank 2. Then it is 19, it will have 3. After 19, it becomes 15, it is 4. Now after 15, 13 and 13, 6 and 7, 4 ranking has been used, 5 and 6. So 5 and 6, both are the identical numbers, add it up, 11, and this has to be divided by 2. So 5.5 and 5.5. 5, 6 ranking is gone. Now 9, it is 7. Now again identical numbers and here are 2, 2. 7, now once again 6 and 6, 8 and 9, 17 divided by 2. So 8.5, 8 and 9 ranking is gone and the smallest number is 4, it will have its rank 10. So this 3, 2, 13 and 13 in Y series and once again 6 and 6 in Y series. So these are 3 repetitions in this particular sum and it must be denoted by R1, R2, R3. Now we have got the rank, so now as before we must calculate absolute D and then this has to be squared. So the difference of these two, so it is 2.5, it is 0.5, it is 3, it is 1.5, 4, 2, 1, 1.5 and 1. So this is how we get D and finally it has to be squared up. So 2.5, 6.25, 0.25, 9, 2.25, 16, 4, 1, 1 and it is 0.25. तो इसमें थोड़ी सी
3 minus 1 नहीं
3 to 1 is here.
1 ही
1 has to be a square. So that number was missing probably. That's why it was done. Yes, one number was missing. So now it has become 41. And this is summation d square. And when this has been obtained, now a Spearman rank correlation rho xy, since there are 3 repetitions, so 3 additional components will be added up in the original formula. So 6 and summation d square plus r1 cube minus r1 by 12 plus r2 cube minus r2 by 12 plus r3 cube minus r3 by 12 and whole divided by n and into n square minus 1. 1 minus 6, summation d square is 41. R1 is 3. So 3 cube minus 3 by 12. R2 is 2. 2 cube minus 2 by 12. Once again 2 cube minus 2 by 12. And this is 10 into 10 square minus 1. This is 1 minus 6, 41. Cube of 3 is 27 minus 3, that is 24 divided by 12. So this is 2. And this is cube of 2, 8 minus 2, 6 by 12, 1 by 2. So this is 0.5 and this is also 0.5. And divided by 9, 90. And now it becomes 1 minus 6 into 43 and 44. 44 divided by 990 and this is 1 minus by 990, so 726 by 990 and it will come around 0.73. So this is how Spearman rank correlation is calculated in 3 situations depending upon the nature of the sum, and when it is a case of repetitions, then only few additional components are being added up in the original formula. Like Karl-Pearson correlation coefficient, this rho xy always it also lies between minus 1 and plus 1. It also carries the same property. And so regarding correlation chapter, I have explained whatever was important from the postgraduate or the net or either from this stand up to that extent, what was the needed, I have done it up. Now next comes linear regression analysis. Quite attached to this one, I'll explain in next class. In next class, I'll be starting linear regression analysis. This is all for thanks.